All right, we're going to look at the paired t-test. So this is our data that's coming from a matched pairs experiment or study. And we're looking at that difference of means. Okay, so our hypotheses for this are related to what's called mu d, or the average difference. So remember, we have that before and after column, and we subtracted them to get a differences column. Mu d is that average of the differences column. So our null hypothesis is that there's no difference between the two columns at all. And then our alternative hypothesis will either be that they are greater than 0, less than 0, or not equal to 0. And at the bottom of this page, there's actually a little breakdown of how these hypotheses work. So if you think that the mean of the first thing is less than the mean of the second group, okay, I can subtract that guy over. And so I'm looking at mu1 minus mu2. That is my mu d is less than 0. If I thought that mu1 was greater than mu2, then I'm looking at mu d is greater than 0. And then the not equal to one is pretty self-explanatory. We have the same assumptions and conditions as we did for the paired t interval. So some sort of random sample with paired data. Our differences column is either normal or we have a large enough sample size. And then our standard deviation from the differences column we need to find. We'll call this a paired t-test. So we get t is equal to d bar. And really, this is d bar minus our null hypothesis. But because our null is that there's no difference, we would just be subtracting 0 there. And then we have that's divided by the standard deviation of the differences over the square root of n. There's a couple of ways we can get our p-value from this. So if we actually did this work here, okay, we came up with our test statistic, we can plug that into one of these formulas here, like we did with our one mean t as in Tiger test. If we have the two columns of data, this won't give us our test statistic, but it will just give us our p-value. You can highlight the first column, then the second column, then you put a comma, and you tell the command whether you have a one-tail or a two-tail test. Then you put a comma and you put a 1, which is the command for paired. There's also a way to do a paired t-test on there, and so we'll take a look at that as well. Our conclusions remain the same. If p is smaller than alpha, we do reject the null, meaning that there is some sort of difference between these two things. If p is greater than or equal, we do not reject the null. So our conclusion is with a p-value of blank at the blank percent significance level, we do or do not have sufficient evidence. The mean difference of, and whatever that might be from the problem, is less, more, or different than. Okay. So let's go ahead and take a look at an example in the next video.